Next up, we got for each of the formulas that were used in the previous exercise, we must determine if those formulas, each of them, is a equivalent formula uh, semantically. So semantically equivalent. Oh, actually, sorry. Let me put this in a straight order. For each of two, we must write the semantically equivalent. And by the way, another word for semantically equivalent is a, let me try to pronounce this, a tautology. So, what does this mean? It means that, so if we have this formula and we have this formula, if the semantic values, sorry, I meant to write an arrow, if their semantic valorations are equal. That's what semantically equivalent means. Okay, so that out of the way. So for each of those two, no, sorry, for each of the formulas in question 2, we have to verify if they're semantically equivalent. Let me write this with Roman notation, so semantically equivalent, or a tautology, or tautologically equivalent, or if they have the same valoration, semantic valoration, you can say this in many ways. You just pick the one you like most and you employ it and do your best to recognize other people's use of their preferred semantics. Yeah, it's not very standardized, but it's what our ancestors predefined for us. So eventually we may change it. I'll begin with my own take on this, which is how I see it's the simplest syntax, which is devaloration. But it's important to be able to recognize the others. Okay, so the first one is we want to discern if they're semantically equivalent, aka they have the same valoration, semantic valoration. So you can see these are 3 words. This is 2 words and this is 1 word. And depending on the context of the text that or manual that's being used, maybe for brevity they need 1 word. Maybe contextually it sounds better doing it with these or those. So yeah. I just think we should go with effectiveness. So pick whichever fits you best for now. For me it's this because I'm a noob in this area. So okay, so the first one So for each of the ones and two, we have to verify if they are semantically equivalent, and then we have to also verify if they are satisfactory and if we were to backtrack a little bit, I need to refresh this myself, to be honest. So a satisfactory model is whichever evaluation returns 1. So let's bring that up here. So it has to be satisfactory. So which is a valid model, same as valid model, and that means that V, or the actual valuation, must be 1. Okay. And on this third part, so the third numeral, we have to check if it's a contradictory. Now let's see what that meant precisely. So a contradictory model is one which results in an untruth, a 0 or a false. So if a V or a invalid, in which V, the absolute valuation, is 0. So let's begin. Initially we had a, actually let me demarcate the point of definition and that of results. So we had on the previous example we had A, then B, then C, and finally a D, and we want to check in regards so we want to check in this problem if they are semantically equivalent, if they are satisfactory, valid model, and if they are contradictory or an invalid model. This is quite easy because if this is true, this must be false. If this is false, this must be true. Or one's numeration. 1 and 0. Thus, this will be an easy exercise, I think. Okay, so let's begin. A, the result that we obtained was 1. And then we got 1, and then 0, and then 1. Let's just make sure 1, 1, 0, 1. Yeah. Next up, so, sorry, forgive me, the result for each 1, 1, 0, and 1. Okay. That done, we need to know if it is a tautology. And so neither of them, just straight out of the box, in none of those exercises use the same formula, so all of them are semantically different, which means that they are not a tautology. Okay, so none of them are. So let's say 0, 0, 0, 0 representing false. And then we get simple satisfactory for a, we got 1, so it will be 1. It is satisfactory. And it will be this exact result, so 1, 0, and 1. And if it is contradictory, so if it returns 0, that's the question that we want to perform on the result when we look at if it is contradictory or not, the result of the application of the function. And in this case we get the exact opposite, so this is false, false, true, false, and that's the solution for this problem.